So now today lecture we can start the rotational motion. Rotational motion. The rotational motion we are going to start, right? The rotational motion may be classified into many types. The rotational axis about fixed axis, rotational about the moving axis, and the rolling motion. So there may be the many types of the rotational motion. First of all, we are discussing the rotational motion about fixed axis. Rotational motion about fixed axis, For example, if you consider the fan, right? If you consider the fan, so this fan is moving about a fixed axis. The motion of the door of your house, of your room, it rotates about the fixed axis. Suppose this is the body, are you getting? And this is the axis. This is the axis of rotation, and it is rotating with angular velocity omega. All right. So if you consider any particle, this is the solid body. If the number of particles, if you consider, suppose this is the m1, m2 and m3. So the radius, this is the axis of the rotation. If this is r1 distance, r2 distance and r3 distance, so many particles are performing circular motion about the axis of rotation. Every particle present on this solid body, this is solid body, right, performing the circular motion about their axis. If the angular speed is omega, can you tell me what will be the speed v1, v2 and the v3? The speed v1 is equal to r1 omega, v2 will be equal to r2 omega and v3 is equal to r3 omega. Although the radius of all the particles are different, but they are moving in the circular path, right? These circles are parallel to each other, and the time period of revolution is the same because they are performing the rotation motion about the fixed axis. If I want to write the kinetic energy of all the body, so half m1 v1 square, half m2 v2 square, like this, half m n vn square, right? So what is the velocity v1? r1 square omega square, m2 r2 square omega square and mn rn square omega square, right? If you take half common, then you will get m1 r1 square, m2 r2 square and mn rn square. This is the omega square. So this is the kinetic energy of the rotated body. This is the rotational kinetic energy. You will see m1 r1, m2 r2 and mn rn square. If you assume this is a constant, suppose this constant is I. So if you consider this the I, so the rotational kinetic energy is half I omega square. Is it clear or not? So in the translation motion, if you consider this is the mass m, it is moving with the speed v. So what is the translational kinetic energy? Say half m v square. Rotation motion is very much similar to the translational motion, right? And you will see in this case rotational kinetic energy is what? Half I omega square. Here v is the speed or the velocity, you can say, right? Velocity. And here omega is the angular speed or angular velocity. Here the mass m is the mass or the inertia of the body. Here this is the inertia in case of rotational motion. Inertia in case of inertia of the rotating body. And this is called the rotational inertia. Also it is called the moment of inertia. So this I is the moment of inertia, m1 r1 square, m2 r2 square and so on. Is it clear or not? So if you consider the translation motion and the rotational motion, what the role is played by the mass in the translation motion, the same role is played by the moment of inertia or the rotational inertia in case of rotation motion. What is I? It is the inertia in case of rotational motion. Are you getting or not? In this case, the mass is constant, it does not change. But the moment of inertia depends upon the mass as well as the distance of the mass from the axis of rotation. If the distance is more from the axis of rotation, its rotational inertia is more. Are you getting or not? So it depends upon the mass and the distance of the point mass from the axis of rotation. Right. What is the SI unit of inertia or the moment of inertia? Kilogram meter square, and it is a scalar quantity. Scalar quantity. Do you understand this thing? Copy this. Yes, Varsha, do you understand this concept? So this is the moment of inertia for point masses I have written, right? So this moment of inertia depends upon what? It depends upon the mass of the body and the distribution of the mass of the body from the axis of rotation. I depends upon first the mass of the body, and second the distribution of mass with respect to axis of rotation, Is it clear or not? That's it. So for example, suppose this is the square plate, right? This is the mass, this is the mass, this is the mass. Suppose this is the 2 kg, this is the 2 kg, this is the 4 kg, and this is the 4 kg, right? And this is the axis of rotation. The axis of rotation is this, right? This is the axis of rotation. This is the plane of the square. This is the 5 meter and 5 meter, right? So you have to find the moment of inertia about this axis of rotation, AA dash. You have to find AA dash. Are you getting or not? So for point masses, this is the formula. I can assume, listen one thing. If this is the 2 kg M1, what is the distance of this point mass from the axis of rotation? Say 0. For if you assume this is the M2, so what is this? What is the R2 distance for this point mass? Say 5 meter. Is it clear? Yes. If I assume this is the M3, can you tell me what is the distance of this point mass from the axis of rotation? If it is 5 meter, what is that? 5 root 2 meter. And if I assume this is the M4, what is the distance for this point mass? Tell me. 5 meter, right? So I can write 2 into 0 plus 4 into 5 square plus 2 into 5 root 2 whole square plus this is 4 into 5 square. 5 पंजे 25 चौका 100 plus 5 पंजे 25 दूनी 50 दूनी 100 plus 100. This is 300 kilogram meter square is the moment of inertia of this particle of system, right? Copy this. For example, one more question this type. Suppose this is the 4 meter, this is the 3 meter, right? And the body is 2 kg over here. This is the 2 kg, this is the 4 kg, and this is also the 4 kg, right? And the axis of rotation is passing through the plane. This is the 2 kg passing through the plane, right? And this angle is 45 degree. This is the rectangle and the point masses are placed. So can you find the moment of inertia about the axis? Find I AA dash. AA dash is the axis of rotation, right? This angle is 45 degree and this is 3 meter and this is 3 meter and this is 4 meter, right? Assume this is also the 4 meter, right? And this is 45 degree. Are you getting or not? So about this axis, if you assume this is the M1, so this is present on the axis. So R1 is what? Say 0, right? And if you consider this is the point mass, if this is the axis of rotation, this point mass is rotating about this axis like this. So it would be the radius r2 if I assume this is the m2. In the same way, if this is the point mass, I assume this is the m3. So it is rotating like this in this circular path. So this is what? Say r3. And this is the point mass and this is r4. Are you getting or not? You tell. M4, this is the M3. Right. So what is the moment of inertia about this axis? The moment of inertia about AA dash is equal to M1 into 0 plus. What is the M2? So this distance we have to find. If this is 45 degree and this is the 4 meter. So what is R2? Yes. Sine 45 is equal to what? Perpendicular upon hypotenuse upon 4. This is 1 by root 2 into 4 is equal to R2. R2 is equal to what? 2 root 2 meter. In the same way, if this is the R2, the R4 is also equal to the 2 root 2 meter. Is it clear or not? And what about the R3? What is the distance? It is 4 meter, it is 4 meter. So it is 4 root 2 meter. Getting or not? So M1 R1 square plus M2 into R2 square plus M3 into R3 square 4 root 2 square plus M4 into 2 root 2 ka square. Then we can simplify this into 4 into 2 plus 4 into 4 चौक 16 दूनी 32 plus 4 2 दूनी 4 दूनी 8. Right, 16 plus 4 दूनी 8 4 तिया 12 चौक 32. Right, 128 plus 32 plus 16 4 दूनी 8 दूनी 16 हंस लग गया 1 5 तो 7 176 किलोग्राम मीटर स्क्वायर is the moment of inertia. Right, 4 2 8 16 हंस लग गया 1 3 और 2 5 6 और 1 7. Copy this. So if this is the 2-point mass system M1 and M2, this is the very important question, and the distance between them is r. Right, if you have to find the moment of inertia about an axis which is perpendicular to the line joining M1 and M2 and passing through its center of mass. So this is A dash, right? So you have to find the moment of inertia IA dash. In English, what they will give, you have to find the moment of inertia about an axis passing through its center of mass and perpendicular to the line joining the 2-point masses M1 and M2. Right. So if this distance is R1, right, and this distance is what? Say R2. So IA dash is equal to what? M1 R1 square plus M2 R2 square. In the center of mass, the R1. Did you remember what is the R1? Tell me. Did you remember M1 R1 is equal to what? M2 R2. So R is proportional to 1 upon M. So in R1, when you will write R1, what will come? M2 upon M1 plus M2 into R. In R2, M1 plus M2 into R. Did you remember or not? So in R1 is what? M2 upon M1 plus M2 into R whole square. M2. M1 upon M1 plus M2 into R whole square. This is the value of R1 and R2 you have to remember. R is inversely proportional to mass, right? So in this way you can remember. So what will you take common? M1 M2 upon M1 plus M2 if you take common. So from here the M2, from here the M1, and the R square is common. So M1 and M2 will cancel out, right? If you simplify, you will get M1 M2 upon M1 plus M2 into R square. Again, this is the moment of inertia and this is the reduced mass into R square. So about the center of mass, about the axis passing through the center of mass, the moment of inertia you will remember mu into R square, where mu is the reduced mass, right? M1 M2 upon M1 plus M2. So you can remember in this way. Copy this. Okay. For now, I will discuss the moment of inertia. Moment of inertia for solid body. This is the important thing. Solid bodies, right? For example, first I will consider the rod. This is the rod of mass m, length l, right? Listen one thing. As I told you, the moment of inertia is nothing but the inertia in case of rotational motion, right? Which play the same role as it is placed by the mass or the inertia in case of translation motion. So if the in case of translation motion, if the mass remains constant, but in case of rotational inertia can change if the axis of rotation is changed. For example, if this is the rod, if it is rotated about the one end, and if it is rotate about the midpoint, about axis passing through the midpoint, so both moment of inertia are different. In this case, we are going to find the moment of inertia about an axis passing through the one end, right? Copy this. So how to find this? Listen one thing. What will you assume? We don't know the moment of inertia of this whole body. So what you have to do? If even we don't know the moment of inertia, what can we write? We can write at distance x, a very elemental portion of the width dx, and the mass of this body is dm. All right, of this part is dm. So I have chosen an elemental part of the mass dm, right? Elemental part of mass dm, and it is rotating about x-axis like this, right? So what is the distance? Say x. Even I don't know the whole moment of inertia of the body, but I can write by assuming this is the elemental mass as a point mass. So for this elemental point mass, the elemental moment of inertia dm into x square I can write. Are you getting or not? What is the dm? Dm is the mass of this part. So how to write the dm? Using the unitary method, right? If you consider the length L, for the length L, what is the mass? Say m. For 1 meter, what is the mass? Say m by L, right? For the dx meter, what is the mass? Say m by L into dx. So this is nothing but the dm is equal to m by L into dx. Is it clear or not? So the dm mass is m by L into dx into x square, right? So this is m by L into x square into dx, right? So total moment of inertia, how to find? This is the elemental moment of inertia for this elemental portion. How many elemental portions are there? The elemental portion, if you consider the rod, right? These elemental portion start over here from x is equal to 0. Then this is the elemental portion, this is the elemental portion, this is the elemental portion. So elemental portion are present from x is equal to 0 to x is equal to L. So what you have to do? You have to, if its moment of inertia is di1, di2, right, di3, what you have to do? Total moment of inertia is nothing but di1, di2, di3 and so on. That is the summation of di. Summation means the integration of di. So what you have to do? You have to integrate this elemental moment of inertia, right? And the limit varies from, what is the limit? Varshas, can you tell? The limit varies from 0 to L. So m by L is the constant, 0 to L x square dx, and this is m by L x की power 3 upon 3 from 0 to L. So this is m by L cube upon 0. So the moment of inertia about one end is ml square by 3, right? So you have to remember this moment of inertia of the rod if it is rotating about one end like this, right? About one end, the moment of inertia. Copy this. Any doubt you want to ask here? Right. If you ask to find the moment of inertia of this rod about an axis which is passing through the midpoint, so how to find the moment of inertia? In the same way, right? The rod of mass m and length L, this is L by 2, this is also L by 2, right? Can you tell me what is the moment of inertia about the midpoint? Do you remember? Yes, any of you. Listen, you have to remember ml square by 3 about the one axis. Do you understand this thing or not? You tell. Yes. So to find the moment of inertia, we have to choose an elemental portion again. At distance x, this is the dx, this is the dm, right? So what the moment of inertia di I will write? Dm into x square. Again, the dm I will write in the same way. The dm will be equal to what? M by L into dx. M by L into dx into x square. Are you getting? So now to find the moment of inertia, you have to integrate m by L x square into dx. Is it clear or not? You tell. M by L. Can you tell me from where to where these elements are you have to take? The element start from here and it goes to 0 to L by 2. If you consider it 0 to L by 2 integration, then you have to multiply by 2, then you will get the correct answer. But listen one thing, the elements are not present only from 0 to x is equal to L by 2, right? Rather the element are present from x is equal to minus L by 2 to L by 2. So either you choose the limit from minus L by 2 to L by 2, you can get the answer, or the moment of inertia may be written as 2 times of m by L, m by L, m by L from 0 to L by 2 x square dx. Are you getting or not? Either you multiply by 2 because this is the half rod this side, the similar rod is this side, and the moment of inertia is a scalar quantity. So therefore it will be added, or it is multiplied by 2, or you may write in one time from minus L by 2 to L by 2. Either integration you will solve, you will get the answer. Are you getting or not? This is m by L x cube upon 3 from minus L by 2 to L by 2, right? When you will simplify m by L, this is 3, put the upper limit minus the lower limit. Are you getting or not? Right? So this is m upon 3L, this is L cube upon 8, and minus plus L cube upon 8, right? So this is, it become ml square by 12. So this is the moment of inertia, ml square by 12. When you will simplify this, you again get ml square by 12. The same moment of inertia you are getting, right? The difference is only choosing the limit. In this case, minus L by 2, L by 2, then no need to multiply by 2. If you choose 0 to L by 2, then you need to multiply by 2 only. Copy this. Okay, so what is the moment of inertia of the rod about one end? You tell. Tell. ml square by 3, right? And what is the moment of inertia about the midpoint? So you have to remember this moment of inertia. They will be used directly in the questions when we will do the questions of the rotation motion, right? So this is the first step. The rotational motion is the chapter which is divided in two parts. First part is to find the moment of inertia, right? The one question come from the moment of inertia in the examination, and the other question come from the rest of the part of the rotation motion. Is it clear or not? Right. For example, suppose there is a ring. Suppose there is a ring, right? Ring of mass m and the radius r, right? This is the front view. If you consider the ring like this is the ring. So this is the axis of rotation. This is the axis of rotation. This is the ring. So it is rotating like this. Can you find the moment of inertia about an axis? This is the axis passing through the center and perpendicular to the plane of the ring. Axis AA dash passing through passing through center and perpendicular to plane of the ring, because the axis may be like this, it may be the axis. Are you getting? This is the axis passing through the center and this is the plane, this is in the plane of the ring. But we have to find first the axis of rotation is perpendicular to the plane of the ring, and ring is rotating like this. The ring is rotating like this. Are you getting? And it is rotating like this, and the axis is perpendicular to the plane of the ring. Do you know the moment of inertia? Can you tell? Varsha, any of you? Right. So how to find? Okay, how to find this? So you can consider the dm, right? The dm mass. If you consider this, the axis of rotation is like this. So if you consider the dm mass of the ds distance, right? So about this, I can write the elemental moment of inertia dm into r square if it is r, right? So how to find the complete moment of inertia di into dm into r square? The r square is come out from the integration of dm. What is the integration of dm? So complete m, so mr square. So this is the simple, like a point mass is placed at distance r. So this is the moment of inertia. Is it clear or not, you tell? Listen one thing, this is very much similar. Suppose this is the mass. If you consider this is the semicircular ring, are you getting? Semicircular ring, and this is the axis of rotation, right? Or in the 3D, this is the semicircular ring, right? And this is the axis of rotation. This is the axis of rotation. The mass of the ring is m, the radius is r, and this is the complete ring of the mass m, radius r, the moment of inertia mr square. Can you tell me what is the moment of inertia about this axis of this semicircular ring? What is the moment of inertia? mr square only, right? So no change. Even if you take a circular arc, this is the circular arc, right? And this is the axis of rotation, and the radius is r, this is the theta, the mass is m. So even about this axis, the moment of inertia is mr square. Why? Because all the mass is present at distance r from the axis of rotation. So whether it is circular arc, whether it is semicircular arc, or whether it is a complete ring, all the mass is present at distance r from the axis of rotation. Therefore moment of inertia is mr square. Okay, so for this circular ring, the moment of inertia is mr square. Now if you consider the disk, right? The disk is like this, right? This is the disk, and this is the axis passing through the center of mass, a dash. What is the moment of inertia a dash? The axis is perpendicular to the plane of the disk. The disk is mass m and radius r, right? It is half mr square. I will calculate this also. Listen, this is the side view from the top view, right? This is the disk. To find the moment of inertia about this axis, what will you choose at distance x, right? You will choose an elemental ring of the width dx, right? I cannot write the moment of inertia for complete this, but I may write this is the elemental ring, right? This is the elemental ring of the mass dm. I am assuming the mass of this portion is dm and the radius is x. So it is the elemental ring or not? Yes. So for this elemental ring, the moment of inertia dm into x square I can write. Is it clear or not? This is the axis of rotation. This is the axis of rotation. What is the dm? Dm is the mass of this elemental ring. So can you write the dm mass? Yes. In this case, the mass is distributed over the area. So I will apply again the unitary method. For example, For the pi r square area, the mass is what? Say m. For 1 meter square, the mass is m upon pi r square. Can you tell me what is the area, dA area of this elemental ring? How to find the area, a small elemental area for this ring? You just cut this ring and spread like this, right? So what is the width? Width of the ring is what? Say dx. And what is the length? Length is 2 pi x. So what is the elemental area for this small elemental portion? The elemental area is length into width. Are you getting? Right? So for pi r square, the mass is m. For 1 meter square, this is the mass. For this area, what is the area? 2 pi x dx. The mass is m upon pi r square, 2 pi x into dx. So this is the elemental mass, 2m upon r square into x into dx. Do you understand this thing or not? So in finding the di, the dm I will put over here, dm upon r square into x square, sorry, x into dx, and this is the x square. Now you can integrate and you will get the answer. Copy this first. I'm explaining this once again. Suppose if we have the disk, right? We have the disk and we are asked to find the moment of inertia. So how to find? We know the moment of inertia of the ring. If this is the r, this is the m, what is the moment of inertia about this axis? mr square. So what will we do? This disk we will break into the different rings. For example, this is the one ring. If this is the one ring, this is the another ring. So if we divide this disk into the different ring, right? So if we add the moment of inertia of this is the di1, right? Its moment of inertia di2, its moment of inertia di3. So there are so many small elemental rings, di4. If we add them, then we will get the total moment of inertia of the disk. So therefore we have to add mean the integration, right? So to find the moment of inertia of the disk, we have to use the integration. For how to use the integration, we will write first the moment of inertia of elemental part. Suppose at distance x, the width is dx. We are considering the elemental ring, right? We are considering, if this is the disk, we have to consider an elemental ring at distance x. This is the elemental ring. We don't know the complete moment of inertia of the complete disk, but we know at least the moment of inertia of this small ring. If the mass is dm, so the elemental moment of inertia is what? Say dm into x square. So the thing is that when we will integrate, in the integration there should be only the single variable. Here the dm is the variable, x is the variable. So we need to convert this dm we have to convert into the x. All right. Now we have to write this mass dm in terms of x. For that, this is the planar body. If the body was linear, the mass was distributed over the line, over the length. But if it is the planar body, the mass is distributed over the surface area, right? So first of all, tell me, if I choose at distance x, the width is dx, right? What is the area of this portion? Can you tell me how to find this area? How to find? Some student may write the area is pi x square. No, pi x square is what? The area of this circle. We have to find the area of this thick disk, thick annular disk. So to find this area, what we have to do? There is a simple method. Cut this and spread this. So if you cut this and spread this, so what is the width? Width is dx. And what is the length? Length is 2 pi r, 2 pi x. So what is the elemental area of this disk? It's 2 pi x into dx. Is it clear or not? Varsha. Right. Now How to write the mass? For the total area pi r square, the mass is m. For 1 meter square, the mass is m upon pi r square. So if you write down the mass of this portion, what is its area? Say 2 pi x into dx, right? So its area mass is m upon pi r square multiplied by its area. So when you will simplify, pi will cancel out. It is 2m x into dx. So this is the mass dm. All right. So for the finding the moment of inertia, we have to put dm. Now we can integrate this. The constant term will come out from the integration x into x, x cube into dx. Now you have to integrate. You will get the moment of inertia. Listen one thing. From where to where the rings are forming, x is equal to 0 to x is equal to r. So all the rings, this is the di1, di2, di3 up to what? 0 to r, you have to integrate. You are getting the integration limit. Varsha, yes. This is x की power 4 upon 4 from 0 to r. When you will put the value, r की power 4 upon 4 minus 0. This is 1 by 2 mr square. Is the moment of inertia of the disk is half mr square. You have to remember this. Right? Listen one more thing. So the moment of inertia of the disk and the ring, you have to remember. Right? Like this. Listen one thing. If you consider the hollow cylinder, how the hollow cylinder? This is the hollow cylinder. The radius of the hollow cylinder is r, right? So this is the axis of rotation. The axis of rotation is passing through the axis of symmetry. If this is the radius r, the hollow cylinder is mass m, radius r. Can you tell me what is the moment of inertia of this hollow cylinder? You tell. Yes, Varsha, any of you? What is the moment of inertia of this hollow cylinder about this axis? You don't know? Listen, the hollow cylinder is similar to ring. Right? The moment of inertia is mr square again. How it is? I am explaining. Suppose this is the ring of mass m1, the radius is r. Right? What is its moment of inertia? m1 r square. If you put another ring over it of the mass m2 of the same radius, then its moment of inertia, the moment of inertia is a scalar quantity, it is just added. If you put another ring of the mass m3 of the same radius, the moment of inertia mr square. If you put another ring of mass m4, if you put another ring like this, so cylinder, hollow cylinder is nothing but the combination of ring stacked one over another, right? If you consider this is m5, so m1 plus m2 plus, if you take the m1 plus m2 plus m5 r square, so it is the mass mr square. So it will be formed a cylinder or not, you tell, right? So the hollow cylinder is similar to ring. And what is the moment of inertia? Say mr square. This is the one way. Another way to take the element and to integrate this, but it is useless. You simply just write like this. Are you getting or not? Listen one more thing. The solid cylinder of mass m, radius r. What is the solid cylinder? Solid cylinder is like this. Solid mean everywhere it is solid. What is the moment of inertia of the solid cylinder? It is very good. It is similar to disk. Getting or not? How it is? Again, if there are so many disks, this is the one disk, right? This is the another disk, right? There is another disk, right? The another disk of same radius, same radius. So when disk over disk over disk are placed, so they will form the solid cylinder, right? The masses are added. So what will be the moment of inertia of the solid cylinder? Say mr square by 2. The hollow cylinder similar to ring, solid cylinder similar to disk. The moment of inertia is half mr square. So I think it is clear that the solid cylinder and hollow cylinder are, these are similar to ring, similar to disk. You tell me, what is the moment of inertia of the disk? You tell. If about this axis, what is the moment of inertia versa? You tell. Say, yes, mr square by 2, right? The mass is m, the radius is r. Suppose if I cut the moment of inertia, the semicircular disk like this, right? This is the semicircular disk. This is the axis of rotation, but this is the semicircular circular disk, right? The mass m and the radius r. Then what is the moment of inertia? You tell. Should I explain this? Should I explain this? Right, right. Okay, half mr square. Even if the quarter circle is over there like this, if this is the quarter circle, right, like this, and this is the quarter circle, right? Even if the, but m and r should be over there. Moment of inertia what? mr square by 2. Even if you take a sector, right, like this is the sector, and it is very much similar to the disk. The mass is m, radius r. What is the moment of inertia? Say half mr square. Are you getting or not? For this type of the cylinder, I'm making the figure only here, right? If this is the solid cylinder like this, right? This is the solid cylinder, and this is the axis of rotation, right? This is the hemi solid cylinder, half semi cylinder, right? Like this, and the axis of rotation is this. But the mass is m, radius r. What should be the moment of inertia? Say half mr square. Are you getting? No change, right? Even if this is the hollow, this is the part or the hemi half hollow cylinder is like this, right? The hollow cylinder is like this, right? So if this is the axis of rotation, the mass should be the m, the radius should be r. Are you getting or not? So what is the moment of inertia? Say mr square. Are you getting or not? The mass is m, the radius is r. The moment of inertia is half mr square. Is it clear or not? Listen one thing. If this is the disk, the moment of inertia is half mr square. If I cut the disk half disk is cutted, right? Half portion is cut off, right? So this is the remaining portion, right? This is the remaining portion. So can you tell me what is the moment of inertia in this case? mr square by 4. Do you understand this thing or not? Why it is so? Because the total mass is m. This time is mass is m by 2. So this is the m by 2. If the mass m, the moment of inertia is half mr square. This is similar to the, this is valid for solid cylinder and the hollow cylinder also. One more thing. Can I clear this? Okay. So can you find the moment of inertia of the annular disk? Annular disk. What is the annular disk? This is the annular disk, right? This is the portion, it is cut off. This is the annular disk. This is the radius r1 and this is the radius r2. Can you find the moment of inertia? Yes, about this axis AA dash, IA dash. Do you understand the annular disk, Varsha? The mass is m. The total mass is m. The inner radius is r1 and outer radius is r2. You have to find the moment of inertia. How to solve this? How to get the moment of inertia? Listen one thing. This is the side view. Side view. I'm making the top view. Right? Top view. Top view when you are looking from the top. So you will see this type of the system. Are you getting or not? You tell. This is the radius r1. This is the radius r2. The material is over here. Right? So you have to find the moment of inertia of the disk about this axis of rotation. Are you getting this thing or not? You tell. So the mass is distributed of the area. First of all, yes. How to find? Can you tell me? Definitely we have to integrate. What we have to choose? We have to choose the small rings. And we have to integrate them. If this is the ring I have choose of the width dx and the mass is dm. So can I write the moment of inertia of this small portion? This is the small portion. What should I write? Di is equal to, say, dm into x square. Are you getting or not? Now, if you integrate this, then you will get the answer. But the problem is that in the integration there are two variables. So dm must be in terms of the x, right? Then we are able to find. Yes. Copy this. I mean, how to apply the unitary method? Can you tell me what is the area over which the mass is distributed? Pi r2 square minus r1 square. This is the area. In this area, the mass is what? Say m. So in 1 meter square, what is the area? Say m upon par I2 r1 square. Although this is the mass per unit area, sometimes it is called the surface mass density in kilogram per meter square. This is what? Surface mass density, right? Sometime it will be used in further questions. So this is the surface mass density. What is the area of this small disk, small elemental ring? I think you can find now. 2 pi x into dx. Very good. So what is the mass? So for 2 pi x dx, what is the mass? r1 square into 2 pi x dx, right? And this is the dm. M upon r2 square minus r1 square into x into dx. Is it fine? Very simple. Now you can integrate. The dm is what? 2m upon r2 square minus r1 square into x into dx, and this is the x square. Yes, copy this and simplify. Also, can you tell me what will be the limit of the integration? This ring start from where to where? Can you tell? Yes, these are the ring. This is the one ring. This is the another ring, right? Like this. This is the another ring. This is the final ring. So these rings are made from x1 is equal to r1 to x2 is equal to r2. So the limit will varies from r1 to r2. Please copy this. So if you want to write the moment of inertia, so this is the constant 2m upon r2 square minus r1 square will come out from the integration, right? And this is x into x cube dx from r1 to r2, right? 2m upon, I am writing here, 2m upon r2 square minus r1 square. The integration is 4 upon from r1 to r2, right? So 2 and 4 will cancel out. M upon 2, r2 square minus r1 square. Put upper limit, r2 की power 4, r1 की power 4. A square b square, the formula I can apply. This is 1 by 2 m r2 square minus r1 square. A square plus b square and a square minus b square. It will cancel. So 1 by 2 m r1 square plus r2 square is the moment of inertia. Is it clear or not? You tell. This is the answer. So this is the disk, the moment of inertia we have found. Listen, the rectangular lamina, rectangular lamina, rectangular lamina or rectangular plate, the thing is same. Suppose this is the rectangular lamina like this. This is the side A, this is the side B, right? And this is the axis of rotation. Rectangular lamina, mass is what? Say m. Can you find its moment of inertia about this axis? A dash. Yes. Can you tell what is the moment of inertia of this rectangular lamina? So suppose this is the rectangular lamina, This is the side A, this is the side B, right? And you are rotating this book about this axis of rotation. Are you getting? So to understand the axis of rotation, it is very important. This is the axis of rotation. This is the axis of rotation, right? So how to solve this? In very easy method, first I will tell you. You tell. This is rectangular lamina. For one end, it is like a road. It is similar to road. Similar to rod, right? A rod. The IA dash will be equal to what? Say MA square by 3. How does it come? I will explain. Listen one thing. Suppose this is the rod of the length L, mass M1. Are you getting? Another rod, mass M2. Another rod, mass M3. Another rod of same length M4. Are you getting or not? What is its moment of inertia? About one end, ml square by 3. Did you remember or forget? About one end, the moment of inertia. For this rod, m2 square L, m2L square by 3. For other rod, ml square by 3. Are you getting? So m1 plus m2. So when the many rods are placed over one another, they form what? They form rectangular lamina. So m1 plus m2 plus m3, right? L square by 3. So what is the total mass of the system? Total mass of the system is m, L square by 3. Is it clear or not? You tell. So about one end, the rectangular lamina act as a rod. So this is the rod. Do you understand this thing or not? Even you can think like this. If this is the rod, this is the rod now. The moment of inertia about this axis, say ml square by 3. If the mass is distributed like this, it is open. So mass is just only distributed, it is spreading, but the distribution of the mass with respect to axis of rotation is very much similar. This mass is same. Are you getting? So what is the moment of inertia about this axis? Say ma square by 12. If I ask about this axis, what is the, if it is b dash, what is the moment of inertia I b dash? You tell. M b square by 3. This is the thing. Otherwise, by the integration, you can also find the moment of inertia. But no need to do that. You have to remember this, it is similar to the rod. This is the length of the rod, ma square by 3. This is the length of the rod, mb square by 3. That's it. Copy this. Also, listen one more thing. One more thing. If you take this rectangular lamina, right? Can you tell me if rod is like this, what is the moment of inertia about this? Tell. ml square by 12, right? So if this is the rectangular lamina of the side A, if you rotate this about this axis, this is the axis of rotation, this is the axis of rotation. So what is the moment of inertia about this axis of rotation? M square by 12, right? About this axis of rotation, it is rotating like this. What is the moment of inertia if it is B? mb square by 12. since it is similar to rod. Are you getting or not? Copy this, copy this.